so that there's a little less interruption there. Okay, so here is, and I don't know if you just see what I just did, there's a magnifying glass on this. So this is quite helpful. If you click on that, you get a bigger version of the graph. Can you see the larger version of the graph? Did you see it blow up, kind of zoom in?
Yep.
Okay, good. So you can see the bigger version. That's quite helpful because especially in some of the problems later on when it's hard to see exactly what's going on, being able to blow it up and see bigger is really quite helpful. And then the way that I've always done these is basically to just pick a starting point. And I have to say I tend to start around, as far out on the x-axis as the graph goes, primarily because I'm used to that with trig. We tend to start on the x-axis, the positive x-axis, and go counterclockwise. So I tend to use that just as a standard, and then that means that I'm always doing it the same way. That might mean that the equations that I come up with are not exactly what WAMAP is expecting, but it also doesn't necessarily mean it's wrong. Okay, so what I did on when was that? Gosh, it was a long time ago. It was Tuesday. The last time we met was Tuesday. What I did then was I said, if we start here and we look only at what x is doing, and then only at what y is doing, I'll do a separate graph down here, just one thing at a time. What we're saying is that as time goes on, so if time is my variable, what happens to x? This is a function of x in terms of t, okay? And now I've made this quite small because I want to be able to get another one on the screen as well. So at t equals 0, x equals 10, and I can just choose my scale. It doesn't really matter what my scale is. And as time goes on, x changes. As you can see, x is getting smaller here and smaller and smaller and smaller until it gets down to about 3. So I'm actually going to plot that. I'm going to say, let's try a different color here since I have this capacity. X starts with a value of 10, and then it gets down to a value of 3 before it starts to go back up again, right? When it does go back up again, it only gets up to about 7, and then it starts to go back down. And when it gets down to its next sort of minimum value, that minimum value is about -2. So now I have to go all the way down here, -2. Okay, so can you see what I'm doing here? I'm just tracing x, the behavior of the x coordinate or the x value at its highest and then lowest points, alternating as I go around the graph. All right, so the next one, if I keep going, I'm tracing the graph, I'm tracing the whole loop, but I'm really only interested in x. I'm kind of doing this, 10, -3, or sorry, 10, 3, 7, -2, and so on. I'm really just tracing the values of x back and forth. I got down here to -2. My next value of x that's either a maximum or a minimum is +2. So when I graph that, it'll look something like this. And if I keep going, I'll get down to -7. And then I'm going to come up to -3. I think I need to move that down just a little bit, that -7, maybe more like here. Then -3, which is just a little lower than -2 was. My scale is quite small in the vertical direction, so it makes things a little bit difficult. But notice that I'm not really being terribly precise. I'm really just kind of recording approximate behavior. And the precision comes out once we finish the graph and we type it in and we can tweak it a little bit. Okay, so I've got down to, let's see, I got up to +2 and then down to -7 and then up to -3. And my next value for a minimum or a maximum value for x is -10. So now I'm all the way down here at -10. Okay, and keep going in the same direction, and you're just going to keep going back and forth for x. But it turns out now you'll notice that we're going to get to the same value here for x as we did down here. We're going to get up to -3. So you'll start to see some symmetry, not only on the graph, the loopy graph, but also on the graph that you're producing yourself, okay? So there's -3 and then down to -7. Looks like I'm gonna have to extend my t-axis here. See, I was already down to -7 here. Now I'm down to -7 again. Tighten that up just a little bit. Okay. Keep going in the same direction, keep tracing around in the same direction, and you get to x equals about 2. And notice that we were at 2 once before when we were way down here. So up to 2. Let me go ahead and extend my axis here a little bit. Okay, so I got up to 2, keep going in the same direction, you get down to -2. Keep going and you get up to about +7. Down to +3, and then eventually back to 10. And it looks like my points, my dots got farther and farther apart as I went along here, but this is sort of the result. But notice that when I started at 10 and went from a maximum of 10 down to a minimum of 3 at this point, and then I went back up to a new maximum. I went from 10 down to 3, but I passed between 9, 8, 7, 6, 5, and 4 on my way. So I was kind of doing this. And then from 4, I went up to 7, but I went through 5 and 6 on my way there. So that makes the graph look something like this. And I can just continue and connect all those dots in this way. Years of practice. And I get a graph that looks something like that. Okay? It is not perfect. It is not polished, but it's good enough for what we need to do. The next thing I'm going to do is, and I can see at this point that this looks an awful lot like a cosine graph, right? So I think what I'll do is say that the equation x of t, I'll have to move this because I'll need more room for my other graph, but I'll put it here for now, looks an awful lot like a cosine graph, cosine of t, okay? But let's see if we can get a little bit more, more precise about that. It looks like a cosine graph because if I take the averages or midpoints of each of these high-low pairs, here's a high and a low, the midpoint of that is here. Here's a high and a low, the midpoint is here. Midpoint between this high and low, and this one, and so on. Take all these midpoints, then I can kind of smooth this curve out, and it looks something like this. And now I think you'll agree you can really see the cosine curve coming through, okay? That really looks like a cosine curve, the red one. So the question now is, well, there are two questions. One is it just the cosine, or is it somehow different from that, the red curve? The red curve really is just a cosine curve. You can see it goes from 0 to what I say the end is here, and I'm going to say it's 2 pi. So it goes from 0 to 2 pi, and it only does it once in that amount of time. And it looks like a cosine. It starts up, comes down to the bottom, goes back up to its maximum, okay? But its maximum and its minimum are not 1 and -1, but neither are they 10. It doesn't quite go all the way up to 10. So I'm going to say that looks like about 8, and I'm going to say then that the amplitude of this graph is 8. Now this is a bit of guesswork, and you'll see as we get, when we actually type these in, what happens if you get the actual numbers wrong, but you'll also see how we can tweak it, okay? Now, for the next piece, what I'm going to do is, let's see, what color should I use here? I have red and blue. Maybe I'll just use a gray one for now, because the next piece is not, I don't need to graph this per se. I just need to look at what's happening between the two graphs. Well, what I want to do is, what I'm really looking for is the equation of the blue graph, right? The first one that I drew. The equation of the red graph is helpful, but it's not the whole picture. So what I want to say is that the red graph, the 8 cosine of t, is kind of like my baseline almost, and that what I need to do to the red graph here to get the blue graph is I need to add a little bit, and then I need to subtract a little bit here, and then I need to add some, subtract some, add some, subtract some, It looks like I'm going to be doing that all the way along the graph, all the way along the entire thing, right? Right from the very first point that I graphed all the way along to the last one. Conveniently, it looks like I've added and subtracted the same amounts as well. It looks like I've added, to add to this is really 8, and I've had to add 2 to that. 8 to get all the way up to where my real graph actually starts, 10, right? So if I've added 2 there, then you can see that what I've added to the red graph here is 2 to get to the blue graph. And then here I've added 0, and here I've subtracted 2. And here I've added 0, and here I've added 2 again. And I don't know if you can see this at all clearly. I'm going to try, I think maybe I'll just do a really fat pen and see if that helps. If I trace out just that one, just as far as I've gone so far, I get this. And I don't know if you can see that, but that looks like, almost looks like another cosine curve. And actually that's exactly what's happening, is I've taken my red graph and I've added to it another cosine curve. So I have a cosine plus another cosine, right? Another way to think of this is if you took this red graph here and you grabbed both ends of it and you pulled it tight and made it a straight line, in other words, made it a horizontal axis, what you would have would be a cosine curve, but along a straight line instead of along a cosine. So the way I like to think of these is the red graph is 8 cosine t, and to that 8 cosine t, I'm going to be adding cosine a whole bunch of times. So let's do this. Plus more cosines. Okay? Now, here's the other piece. We're taking a cosine curve and adding more cosines to it, right? Or we're adding cosine to it, but a whole bunch of times. And how many times have I had to do that? Between 0 and 2 pi, I've had to add, let me go ahead and get my fat pen out here again. I've had to add cosine once. Maybe I'll do it in alternating colors. There's a second cosine. There's a third one. A fourth one. 5, 6, 7. All right. So on top of my red cosine curve, I have 7 cycles of cosine in addition to the red one, right? So I can think of this as cosine of 7t. Remember when we learned how to do the graphing, we discovered that the number that went in here told you how many periods you got between, normally cosine just goes from 0 to 2 pi. But if you had cosine of 7x, for example, then you'd have 7 periods of cosine between 0 and 2 pi. And that's exactly what's happening here. It's just that it's being done on top of a wave instead of on top of a horizontal line. Okay? Now, I don't think I can erase those without erasing the graph underneath it. So I'm going to go ahead and leave that as it is. There's one more thing we need to consider here. And that is that my, I was using blue, so I'll go back to using blue. My original graph had an amplitude of 10. And you can, I say an amplitude of 10, my original graph had a maximum value of 10 and a minimum value of negative 10, which means my overall picture here has to get all the way up to 10 and down to negative 10. So my overall amplitude has to be 10. And right now it's 8, and I need to add 2 to it to get it all the way up to 10. Okay, so that is how I go about finding the graphs, finding the equations of the graph that you see on the screen, the generated graph, right? How do you get the equations of that, the parametric equations of that? Well, this is the process that I use for that. The problem is we've only got one of them, and there are actually 2 equations involved, one for x and one for y. So I'm going to go ahead and put my x equation up there, and then I'm going to create another set of axes so that I can deal with the y. And I'll go ahead and put my scale up here. There's 10 and negative 10. And we'll just do this exact same thing for y as we did for x here a minute ago. one thing to keep in mind is that what I'm doing is tracing this graph out over time. So if x is 10 when at the beginning of the experiment, say when t equals 0, time equals 0, no seconds have passed. If x is 10 there, y is 0. So my y graph is actually going to be starting down here. Okay. So before I go on, before I do anything else, I want to just take a second and pause and ask if anybody has any questions. This is about as far as we got in class on Tuesday, but I did it much more quickly then because we were almost out of time. And I was also assuming that I would see you at least 1 or 2 more times after that, and that hasn't happened. So are there any questions about this process?
Oh, I actually have a few questions.
Yes, go ahead.
When you gather like the points to put on the graph, is it good practice to go clockwise or does it matter?
It actually doesn't matter. I go counterclockwise. So we ended up kind of going this way because that's the way the graph, but when I started in a counterclockwise direction. I don't know if you can see my little cursor arrow. And I started here because that's where I tend to think of in trigonometry. We start on the positive x-axis and go that way. Well, I started on the positive x-axis and then I started tracing my graph in that direction. But what that did was put us in a clockwise pattern. But I always start here and go up, if you will, right? And so for some graphs, that's going to mean looking like you're traveling counterclockwise, and for some graphs, it will look like you're traveling clockwise. But my first sort of step, if you will, is always to go counterclockwise. But it doesn't matter. What will matter is since I started here for the x equation, and I went counterclockwise for the x equation, I must now do the same thing for the y equation. To get a graph that actually completely covers the blue graph that you can see here. Okay. So you could actually start, I don't know, here if you wanted to. I wouldn't recommend it because it's going to be hard to see kind of what's going on. Because we started here where x was at a maximum, we produced a cosine graph. If I had started here instead, for my x equation, I would have been starting with x equals 0 and going down. Well, when x equals 0 and goes up or down, that produces a sine graph. And in fact, because x equals 0 and I went down, it would produce a negative sine graph. That's that transformation, right? So it doesn't matter where you start and which direction you go in, as long as you do it the same way for both the x and the y equations, okay? Now, something to know about that is that if you choose a different place to start or a different direction to go in than WAMAP is expecting you to, it will tell you that your answers are wrong. However, if your graph matches, that's all you need to worry about. Even if your graph completely covers the red graph that this produces, completely covers the blue graph on the screen, then even if the equations say they're wrong, you don't need to do anything else. I'll go in and manually add those points, okay? Does that answer your question, Kathy?
Yes.
Okay.
Also,
yes.
Do we keep plotting our points until we come back to the original point we started with?
Yes, I'm actually really glad you asked that question because yes, you do need to do that. You need to start at wherever you started. You need to come full circle and end up at the same point, okay? Because otherwise, you're not going to get the full picture of you started here. If you don't go all the way around, you might end sort of like here or here. Some people go until they get to they start at a max and go until they get to a minimum, and then it's not at all clear what's actually happening. You need a full cycle of the main graph, right? Of the generated graph. It's really hard to talk about these things when you can't point at them the way you're used to. The generated graph, right? You need to come all the way around the circle or full circle on that graph to get a full picture of what's going on, what equations are building that graph, okay? Anything else?
Nope.
Okay. Feel free to stop me midstream too if you have questions. If something I'm doing doesn't make sense, you're welcome to. I'm happy for you to interrupt. And that goes for everybody, okay? All right, so now I've got the x equation. Let's go ahead and do the y equation. I'm going to do this one a little bit faster just because we're going to run out of time, and I'd like to get it all the way through and show you how I deal with what happens when you get the wrong answer and how to tweak it. The other thing to know is that once we're done here. It takes my computer a little while to convert this video, but it does convert the video, and I'm planning to make these available. So if someone wasn't here, they can see it, but also if you are here and want to see it again, you can go back. And I don't know if you know that YouTube has settings that let you slow down the playback speed and things like that. So know that that is an option as well, okay? And then we can do another one of these tomorrow if we need to. All right, so for y, now I'm going to be looking at what is y doing as I go from here and going this direction. The first thing that happens, notice, is that y is 0. And so I've actually already plotted that point on my graph here, y is 0. And then that's kind of a midpoint, right? It's between a high and a low here, but I'm still going to go ahead and plot it because that's where I started with x. From there, I go up until I get to a maximum of 2, down until I get to a minimum of -7, up until I get to a maximum of -3. -7 is not really quite low enough there. Here, do that. And then up to a -3, and then down to -10, and then up to -3 again. And I'm starting to see some of the same symmetry, -7, +2, and then back to 0 on my way up to 7. So I'm going to go to 2, and then to 0, and then up to +7. So I made a note here. Looks like something doesn't seem quite right here. Hang on just a second. I got down to -10, and then I came down to -10, up to -3. I'm looking at my graph here, up to -3, down to -7, up to +2, and then -2. I missed the -2. So up to +2, down to -2, and then up to 7, down to 3, up to 10, 3, 7, -2, and then back to 0. So once again, I've kind of messed up my scale here a little bit. -2, and then back to 0. So this is actually 2 pi in this case. My scale's a little different for x here than it was for y, right? But in both cases, what I'm saying is one full cycle of the generated graph goes from 0 to 2 pi. So I've kind of adjusted my scale here to make sure it matches. But it is 0 to 2 pi. Right, and then I'm going to do the same thing. I'm going to connect the dots. I'm going to start at 0, go up, and then come down. I'm not doing the greatest job here. I'm used to doing this on the board. I'm not quite so used to doing it on my iPad. It doesn't have to be perfect. So if you're, look, it's a good thing it doesn't have to be perfect, because it is definitely not perfect. Okay, so there's my red graph this time. And if I go in now, oh, I did it the wrong way. I meant for that to be blue. Let's see if I can fix that real quick. Only because I want to be consistent with the colors that I use and what they mean, okay? Okay, so, no, blue, there we go. Okay, so there's my bumpy graph. I like to call that my bumpy graph. And I want to figure out what the smooth graph looks like. I want to figure out what the sort of baseline graph is. So I'm going to take the midpoints between each high and low. There's a high, there's a low. The midpoint between those two looks like it's about there and there and there. So I'm just finding the high and the low and finding the midpoint between them. High, low, high and low. And I'm just eyeballing it in the same way as I was eyeballing, is that 10, is that 3, is that, right? With a graph like this, we have to be a little bit more careful. And here's why. If this is my high, oh, that's a big fat pen. If that's my high, where would my next low be if I was going to continue my graph in this direction? And the answer is it's not 0, right? My next low would be down here, about somewhere down here. And so the midpoint between this high and the next low, or the previous low, is actually the origin there, okay? So that's actually a midpoint, even though it doesn't look like it. And same thing over here. If I were to keep going, my graph would go up from 0, right? So the midpoint is not here, but here, because this graph is expecting to go up. See, it goes up here, so it would continue up here. If I did another cycle, I'd get some more upward movement. That makes this a midpoint here. So I hope that makes sense. I have a message. Do you have to start at the same point for when graphing the X and Y graphs? Yes, you absolutely do, Kushi. You can get correct functions for them if you start in a different place or go in a different direction for each X and Y. But it's the fact that they're starting in the same place and going in the same direction that gives you the graph that it does. So you might get correct equations independently of each other, but it matters that they're correct together. So once you've decided, hey, I'm going to start at 0, 10 for X, then you also have to start at 0, 10 for Y. Okay, good question. Thank you. So now let me connect the dots here now, and I get something that looks like this for my smooth graph. And that looks an awful lot to me like a sine graph. Okay, it's upside down. Sine normally goes up before it comes down. So that's a negative sign. But I would say is that this is negative the sine of t, because it only goes through one cycle between 0 and 2 pi. And then I have to figure out what do I need to add to my sine graph to get the red graph, the smooth graph, to get the bumpy graph. And the answer is I don't add anything at all here. And then I add something here. Oh, sorry, I didn't talk about amplitude here. Red. What is the amplitude of the sine graph here? Looks like it goes, the whole thing, remember, because the graph is going up and down in the y direction to 10 and negative 10, this blue graph goes up to 10 and down to negative 10, okay? But the red graph looks like it maybe only goes up to 6 and down to negative 6. So I'm going to say the amplitude of that graph is 6, okay? Now, if I start thinking about what I have to add and subtract from my red graph, from my smooth graph to get my bumpy graph, the bumpy graph is the one that I'm looking for the equation for. The foundation is this negative 6 times the sine of t. What I have to add to it is a little bit here and then subtract. And if, again, I trace out a single cycle, I get something that looks like another sine graph. So I'm going to be adding sine. Let me back that up just a little bit. I'm going to be adding sine. And then I have to ask myself 2 questions. First of all, how many times do I add sine? And second of all, what's the amplitude of that piece, right? In comparison to the red graph here, how much do I have to add to the red graph, the smooth graph, to get back to the bumpy graph? Let's take a minimum or max, let's do the maximum value over here. If the amplitude of the red graph is 6, then to get all the way up to 10 here, I'm going to have to add 4, right? So that means the amplitude of this piece is 4. I hope that makes sense. In addition to that, we have 1 cycle of sine. Can you see that the red graph, if I treat that like a horizontal line, there's a sine graph on that horizontal line? That's what I'm looking at right now, okay? So I have that one, and then I have another one. And then another one. And then another one, and so on, just like I did with the previous graph. I'm only alternating colors because I think that's going to be easier for you to see, and then for anyone to watch who watches the video later to be able to look back at it and make sense of it. Okay, so now if I count how many of those I have, I get 1, 2, 3. I'm going gray, orange, 1, 2, 3, 4, 5, 6, 7. So again, I have 7 cycles of sine in the same amount of time as I would normally have 1. All right, and that is my y of t equation. Okay, and that's it for how you do this. But now let's take a look at what happens when you actually try to plug those in. Okay, It is 10:15. I'm happy to continue on for about 5 more minutes to try and finish this out real quick. And then we can also pick up right here where we left off tomorrow. Once you have a process, you may have more specific questions to ask me tomorrow. Is everybody happy going on for about another 5 minutes? Why was the first sign -6? The first thing you want, the equation that, or the function that you want to write in here, and this is the same thing as we had up here, is the equation of the smooth graph that you create. And one of the things that you look at with that is, what is the amplitude of that graph? Up here we said, well, that cosine graph looks like it has an amplitude of 8. The sine graph looks like it has an amplitude of 6. So that's where the 6 came from. It's negative because sine normally does this, right? But our sine didn't do that. It went down. It got flipped over the x-axis, so that's why it's negative. Okay, I hope that helps, Levi. All right, so I'm just going to keep going unless I start to see people disappear, in which case we'll stop and I will resume with this tomorrow. So now I have equations for x and y. I'm going to type them in. x1 equals, that's my x of t, 8 cosine of t plus 2 cosine of 7t. And my y equation is -6 sine of t plus 4 sine of 7t. You have to put the parentheses around the t. Sine and cosine, that's how they work. If you don't put those parentheses in, it won't accept it. Now when I hit submit, I get this. And as you can see, I'll blow this up. As you can see, my graph is kind of the right shape-ish, but not quite the right configuration. One thing I can say about that right away is that in my red graph, that's the one that came about because of my equations here, right? The red graph. The blue graph is the one we're trying to guess the equations for. The equations that we guessed are not right. But we're not as far off as we think we are here. First of all, notice that my x, the red graph x, goes all the way out to 10 and -10, and the same thing for y. So my amplitudes are right. And I need to make sure that I maintain that. 8 and 2 is 10. 6 and 4 is 10. I'll talk to you about that negative tomorrow. It's still 6 and 4, right? And those still add up to 10. So one thing I can see right away here is that the blue graph is very symmetrical and the red graph is not. The reason the red graph is not is because I have different numbers here, 8 and 2, than I do here, 6 and 4. So let's change these ones to also be 8 and 2 without changing the signs or anything, okay? When I submit again, now you can see the graph is much more symmetrical, okay? It's still not perfect, but it's much more symmetrical, so we're closer. What's happening here now is that the loops on my graph are way too small, and that means that the difference between these two numbers is actually, the difference between those numbers is also too small. So I'm going to change this so that they are, instead of 8 and 2, I still need them to add up to 10, but I'm going to try 7 and 3. Because my graph is symmetrical, I know I can also change these, need to change these to 7 and 3. See what that looks like? And there's my graph.